So hi everybody and welcome back. This is a C++ tutorial series for absolute beginners. This is video 164, and in this video we continue with our classes and especially where we stopped in our last video. And in our last video we talked about this constructor and member initialization, and we were at the point where we stopped with this example here. Now we understand it and we know that we can define that we can declare functions or variables and all kind of stuff in a struct or a class and define them outside. That is possible, and we will use this normally with this file, with header files and CPP files. Not in this way normally, but we still, yes, there can be cases where people use this kind of definitions for certain scenarios, but in general we put the definition in a CPP file and the declaration in a header file later when we learned how to use them. So with that said, let's continue here a little bit more. And here we jumped right into the next example, and the next example here, it's just a class. You can see it. We have here on top a no access specifier. It starts without an access specifier. We have here just declaration of some variables, say IG, which are all-time bad variable names like all-time, but this is just a demonstration. That's why it's allowed in programming. Don't use stuff like that. But important is here, it starts not with an access specifier like here. Here we know, okay, all is public, which comes after this access specifier. But what happens here? And we learned if there is no access specifier, then the default access specifier counts. And in this case, it's a class, which means the default access specifier is private, which means this one is all private. When we compare this one with the struct here on top, here we have also no access specifier, right? When we watch this one here fast, no access specifier, but in this case it is public because default access of this variables are declared as public. That's very important, so you should know this is private, and that's why they point out it with an access specifier here, public. All what this comes after, so all what comes after this access specifier public, it will be public. You have to point this out then. And then if you want, of course, you can do something like that. Like I said, you can put in access specifiers as many as you want. You can write here again private especially, or you put all the privates here on top. It's up to you. So let's continue here a little bit, and here the next line is a little bit strange. Why I say it's a little bit strange, let's try to figure out why this line is strange. And think about references when you think about this line and why I'm saying it is strange. So I hope you figured it out why it's strange. And the strange thing is, let's make an example fast. I go here to my main function, and we know when we declare a variable, this one is just a variable declaration. The problem is this one is a reference declaration, and we learned on reference declaration we have to assign a value, or let's say an L value normally. If it's not a const, then we know we have to assign here an L value. What was an L value again? That was something like a variable which is already exists, has a storage, and we can access. For example, I create here just a random variable into my special variable, and I assign it here the number 43. And now we know this here, the compiler will create for this variable a special storage, and because it has a special storage we can access this. And this one, this reference, is asking for a special storage, at least a value with a special storage, and I can access assign it this one here. So oops, not so, I copy this one here. Let's copy this one here, let's assign it. And yes, this one we already know when we talked about variables with references. What is the difference when I add here a const in front? I think we have not talked about this one in particular. Of course, I have to write this const first, right? But we have not talked. So what is the difference now? It's better that I make here a new variable so we can distinguish them. let's copy this one here. I paste this one here, and now we can distinguish this a little bit. So the difference about this one and when I write here a const is, in general, we know what a const means. A const means we make just this type here. A const and type const means just you can't change the value of this type, but in this case it has another effect as well. So what is this other effect? You can assign an R value. What was this R value? That was the other part of this L value. L value means you have created in your memory a storage place, and R value means you have not created in your memory and permanent storage place. So it is a temporary storage, which means, for example, if I assign it this value here, again, this 43, this 43 is a literal. This was not created before. This is just used, and this value is temporarily created, has not a specific memory place, and will be only used here. And after we use it here, then it have, for example, here, after you use it here, it will have in this memory place where you have it here a special place. But with const we can use this as well. So for example, if I try to assign here this 43 without const, I can't use that because it says initial value of reference to non-const must be an L value, and this one is our L value. This one is a non-const. Non-const means you have not used this const word, and here I have used it, and I can use this R value. Okay, that was a fast repetition of this what we know so far, what we should know so far. And now let's go back to our strange looking line here, this little line here. Let's copy this one more time. And so what is here the problem? The problem is here the semicolon. Why is this semicolon a problem? The semicolon indicates that this statement is at least till here finished. The semicolon is also a terminator. That means the compiler reads the statement. Then it's considered, okay, finished. I go to the next line. That's it. And we just learned, normally you are not allowed to do this with references, but in classes you are allowed to do that. So, okay, let's say we learn something new in class. You are allowed to do at least, let's say so, at least to use the semicolon here, because it is not true that you are allowed to use a reference. You still have to reference it. But a little bit more about this in a moment. Let's create here also a variable. Instead of using this example, like I said, it's a bad naming. When you start programming, find all time good variable names, and in this case I need a variable name for example for this house class, and all time when you create variable names for a class, try to create variable names which are associated with this class. For example, let's call this one here, I have a house name, I have a house number, and something with a int which can be associated with a house would be, for example, a house flat number, would be also a house flat number. So, and now that is my const int reference. And you see, this is the same thing what they used here. And again, here we have this semicolon, which means end, terminating. The compiler stops here. At least for this statement, it is reading this statement, and then it jumps to the next one. But this one is not true. What I mean with that is, when I saved it, you see here no arrow, but when I scroll a little bit down, yes, there is an arrow here. And this arrow, when we watch this one here, it says something like, this constructor provides no initializer for, and then you see here the reference member, and the reference member is this one. So in a class, the difference is, compared to the normal reference or const reference, the difference is you can make something like that with a semicolon, which means you are declaring something like a reference, but you have to provide still an initializer. The only difference is you are not providing it here, because the class is not constructed at this point. At this point, the class is not, instantiated. They say you have not created an object, right? An object means here just we have nothing created here. But when we create this one, this variable here must be set, right? And the way they do it is they are setting this one in the initializer. So we can set this in the initializer, and it has the same rule as the initializer. You just take here the variable name which you want to initialize. Then you go here, you make a comma. We know we can comma separate the initializer here. Here's the variable name, and we can use again this version or this curly brace version, and then you can assign here a value. For example, again, this 43. Now my house flat number is 43, and now I have initialized this one, and now I have no error, which means it's working. At least we can test this. All time test your code if it's true or not. So when you start, at least it looks that it works. So fine, that's nice. And I think that's all what we needed to know. So the only thing is you have to initialize it. There's one more thing perhaps that I should tell too. This here, when you make something like this one, and I said it must be initialized when you create your class. Of course, if you have more constructors, because I showed you here only one constructor, every constructor must initialize this one. For example, the other constructors must not initialize this one. This is just optional, right? This is optional. I could kick this out and it will still work. For example, I just kick this one out. And of course, the syntax must work, but this one will still work, you see? But this one must be initialized. This is so the difference here. And the next difference was it must be for every constructor, which means if you create here another constructor, let's create here fast and constructor. By the way, I forgot to tell you this as well. What kind of constructor is this again? And last video we already I already explained it what constructor is. This is a default constructor. Even it has here a parameter. Important rule with default constructor is a default constructor can be without parameter. In this case, we have parameter, and if it has parameter, every parameter needs a default value. That's why we can call this constructor as a default constructor as well, which means, what means this again? Fast, when I create here a variable, which means an object of this class. Let's make this one fast. I think we trained a little bit. Here it is in my namespace house. I can see here's the house namespace, and I know in my house namespace I have this big house class, this one, and here again this becomes now my type. I call it here a type, and the type can yes, and then I find here a good name. For example, it is my coder's house. This is just a variable name. And now the important part comes here again with the constructor. Here I can call the constructor this way, that I just make here a semicolon, and this one is calling what? The default constructor. But careful, let me show you something, one more thing. Let's see this one here, and let's call this Maggie's house. Let's call this Maggie's house. And this time I provide a parameter. Let's say Maggie want not the default constructor. Maggie says I want, for example, Maggie's house. And of course you should know what this constructor is doing here. And we can see the constructor here is taking this argument from here in this parameter. This parameter is used then here, and which means Maggie's house argument here is used here, which will be assigned here. And the difference about this too is that Coder's house will be called big house because it's using the default constructor, and this one will be called Maggie's house because it's using a provided argument. And the important thing here is now one more thing, which is why is it this way? Was this possible again? Why I can write here this round brackets and here not this round brackets? Because normally what we learned with functions is if you use function, you have to follow the signature. Signature means all time you have to follow that what the declaration says, right? The declaration says, in our case, In our case, the declaration says it starts this way, and then we have here the initializer and this initializer. And oh, this is not the declaration, sorry. The declaration says here, this one here is the declaration. It starts here with the big house, and then we have this parameter. Normally, what you do is you follow this rule here, which means you are just copying that and you have to use it here as well, like the second one here. This would be the normal, let's say, when we are doing it with functions, but this one is not normal, and the reason for that is we are using here the default values. And I think I have not talked about this, but anyway, it's not too difficult. You can see, oops, that we have here now this default values, and when we are not calling here this with parameters, the compiler will jump just here and will use this value here, and then it can call this definition as well with this value here, and that's why it's called big house later. Not because it is called here big house. Let's say it is here just called house, and here will be default parameter big house. So this variable name here will be called big house, not house, which was initial value. This one is the default constructor value, which is used here. And Maggie is using his own name, which will be replaced here by this parameter, this argument here, and then assigned here. All right, I hope the thing what I want pointed out is that you should be aware we can call them here, and I wanted also show you, of course, this another constructor. When we create another constructor, that was the normal thing what I want to show you, and I show you something else. That's all time cool. So here, when you define here another constructor, all time think about it. Let's make another default constructor. How we can make another default constructor? We just make it without a default value. That would be not a default constructor, but we have here a problem. What is here the problem? Careful, we have here two same constructors. Even this says here an assignment, this is still considered the same. Why is it considered the same? The reason for it is the parameter are the same, and we learned in functions we can the compiler can distinguish a function with the same name, but only then when the parameters are different. In this case, the parameters are exactly the same. So to make them different, I could add here a dummy type, which I'm not using. This is just here to distinguish this one here. And then I know, okay, this one is not used, but let's use this one. Why not? Let's use here, instead of a dummy, let's initialize this value here too. How we can make this? Just copy this one here, paste this here, and write param here. And I know this one should, this is just an info. This param, when I write here parameters, should just give me an info that this name here I want use for that one here. Most time is associated. But you can call this one whatever you want, of course. Important is this one here, what stays here in front, which is our type, right? We learned this kind of stuff. All right, with that said, and I wanted to show you that you have to provide now this strange const int. When you have any reference here, you have to provide for the initialization for this one too. Let's say, yes, let's do this. Let's initialize them as well outside. How we make this? Very easy. We just copy this one here. We make that fast repetition. It's very easy. We are trained, I hope, a little bit. You should all time not just understand them, but also program them on your own, because that's very important. Just understanding is very good. It's for the start, but you have to train it, and train means really typing it out. And so we need again our access specifier, because this one is where placed, and we can point it out with our resolution operator. It's placed in my house namespace in big house. Okay, let's go there. It is in my house class. This is my house class. No, that's not true. It is in my big house class. So let's write first big house. And this one is in the house namespace. Let's write this one also right. So I just repeat this so that you can see that you have to point this out right. So, and then we have now specified this one, and you see it shows here an error because of course I should make a definition, not a declaration. And definition means just provide the body. I have it, but careful, we have again this error. Like I said, for every constructor you must initialize at least this value here must be initialized. This other value is just optional. And most time you won't do it. So what we do again initializer. This initializer is all time this colon, right? And then the things what you want to initialize. In this case, I want to initialize both here. And how I make this again? First of all, you go to the place what you want to initialize. For example, this house name param is my house name. So I copy this one. I go here to my initializer, paste this in. And in round brackets or in curly brackets, both are possible. And then you can use this one or you can provide anything else. Let's use this one. Paste this one and comma separated another, because I want to initialize this one here too. I want to use this argument and initialize with this argument, and this one I have to. This one here in this case. Okay, let's do this, which means I just copy this one again. I copy this one. Here is my comma separated initializer. Nice. Paste in. And here I use this time the curly braces. Of course, when I type right. The point of the curly braces, you see it's a little bit strange here with the body. It can irritate a little bit, I would say. And that's why the most people are using here the round brackets instead of the curly brackets. But this initializer is said to be more safe, and you have to dive a little bit more into it. And it depends on the situation, you can choose. But you should read definitely why they use here sometimes this or that. In this case, I still use it because it's not very important, and I won't use this parameter here because that will be the argument which I want paste here. And now that's it, and we done it. So that was this line here. That was little but very important to talk about it, but especially for starters. And why I'm talking so much about it is also here a reminder. Like I said, this kind of stuff, this definition, you will see in future most time in a CPP file, which means in a separate file. And this kind of stuff here, you will see these declarations in a header file, which means you will see only this kind of stuff. So don't get irritated if you see a variable name with a reference and it has not an initializer. This is only possible in classes, and the class has a class initializer, which is the constructor, and there you have to initialize this value, or this class will have an undefined behavior if this is not the case. So I think now I talked enough about this, and we should go a little bit more in our exercises. And here in these exercises, what you can see here, I think you understand this one very easy now. At least most of the parts, not this part here, but the other part should be easy. You can see we have here a constructor, we can have here an parameter with the constructor, and we have our initializer start here with this colon, and here comma separated initializers, what we initialize here. And what they are initializing is here they have declared on top this variables, this private variables. So we know these are private, and you can see this R is initialized here with this A. Interesting is, and this is also interesting. I think I have not talked about this one, right? They are using this A here to initialize this R here. That's interesting. Most time I showed you examples like that we provide, for example, the caller is providing an argument, the argument is taken here, most time like a function, and then the function, and in this case the constructor, is initializing the value. And here they show us that must be not the case. I can just have here some variables, and I use these variables to initialize this R. But important here again, even you see the semicolon, it has here an initializer in the constructor, very important. So let's continue. I think that's cool. Then again, a comma separated B is initialized with I, and I is initialized with itself. And G, we will talk about this line here special in another video, because these are actually two big topics are here with this little line here. First big topic is this term, this word here, this is special in a class. And we have also talked about this arrow here. This arrow is access specifier, the second member access specifier actually. The first one we already learned. What was the first one again? So for example, I created here an object and here an object. And if I want now access, for example, my coder's house, any variables here to print out, for example, print out this coder's house here name. What is the coder's house name? I don't know what he made. Let's see what he made. We can print this out. What we do is std cout, for example, and then access specifier means you use the variable first. Okay, this is the variable which I created, and now I use a class access specifier, which is our dot, which I learned, which I talked about this one. And here you can see in the tooltip all the public available function. Careful, only public, which means it is not showing the private ones. In my case, I have here no private, but if you would have here private, it's not them showing. And those you can access, of course. And let's see, I wanted the name of my house name, right? And coder's house name, it's here. I select this one. And when I start this program, I can see what my house name is, and you see big house because I used here, we can see I used here the default constructor. The default constructor here is taking just this one here is the default value, not this one is an initial value. This one is the default value of the constructor, and this one will be replaced here, and that's why my coder's house is called big house, and this one is the access specifier. And when we compare it now to this little symbol here, this one is also an access specifier, but specially made for pointers. We will talk in future lessons about classes when we talk about pointers and connect pointers. Then we will talk about this symbol, this member access specifiers for pointers. And this keyword, this term, not keyword, it's this word here, this is special in classes where we have to talk a lot of too. So I think we can go on. This one you should understand at least till this point here. That's good, and this one is for future. Let's watch here a little bit more, and we are soon finished with this side at least. And here in this example, when you watch it, and you can see what we have here. This time they use a struct and they initialize a value here, declare a value and initialize it. And here, this one here is just a normal, I hope you see what this one is now. Here we have a SS means constructor, because it's the same name as like the struct name or the class name. It's the same constructor. Here no arguments means default constructor, our initializer. And interesting is here perhaps this number 7. The 7 is just a random number, so they don't use any arguments. They say it should be initialized to 7, this n here. So in this case, actually, I don't know, I would initialize it directly to 7 here, and don't use here any initializer, because you can't call this anyway, this initializer here. I mean, you are not using here arguments from the caller perspective. So anyway, this is just a demonstration, that's why not so important. And they demonstrate that this 42 is replaced by 7. That is similar to my house here. This is the initial value, and if I call the default constructor, it will be replaced by big house. And that's perhaps interesting to mention here. You have not to call the default constructor here, right? I could call, for example, another constructor, or perhaps I have here even more constructor, which is not even changing this variable here, and this stays all-time house. So in my case, I'm all-time changing it, but if you have here another constructor, perhaps it is not changing this initial value, and it will stay all-time house. And later, if you ask in your variable or object what is the house name, it will say house. Depends on the situation. So that's why that makes also sense a little bit to understand this one, but only if you have here perhaps more constructors. So I think that's not too difficult. Let's go on to the next one. And this one here is very strange, but on another level. Perhaps we are not really discussing it right now, why it is strange. Because here it says error. Let's watch this here. It looks very simple. And look what we have here. It is the thing what we have discussed exactly here. And why I'm saying it is strange. The strange thing is, they say it is an error to assign it here, but actually, I don't know why. On my IDE, it's not an error. It is. They say it is an error, and that's why I'm not sure if we should talk about this one. But let me copy this one and show you what I mean. So they say this is an error, right? Let's copy this one, and this is just a. And if you have so little codes here, you can easily copy this and then put in your own IDE and test it out. So for example, I place it here. Now I have a struct. This is by default public. It's okay. And here we have a default constructor. We have a initializer, and v is here defined, will be initialized to 42. And we learned this one is const, which means we can take an R value. R value is this one. And they say it is an error, but actually, when I create now an type E, let's create a type E. In this case, you start with the type and then you ask, okay, where is the A defined? In global namespace in this case. So it is not defined in any namespace, for example, not in this namespace house. It is defined in global namespace, which means I can use A directly. And then I can write a variable name for this A, because an object name, I call it all time variable. So for example, strange, I call this, it's strange. It is strange. It is strange. And the reason why this is strange, it shows here an error, but when I make this, it is strange variable here. And when I make here a semicolon, and this one means what? When I have here this one, it will call this default constructor, and they say it's an error, but when I start this one here, my compiler says all fine. There is no error, at least not at this point. But let's see. I want now access this value. Perhaps the compiler say it's all right till this point, but if you try to access this value v, perhaps then it's an error. And how we access this one again, like all time, we use the variable name in this case. It is strange. All right, this is this variable name, and then access specifier in this one, this member access specifier. This one is public. You can see we have here no public access specifier, but this is a struct. Struct means by default all are public. That's why I can access this way again. This dot, and I have v available. Let's click it. Okay. And what I want to do is I want to print this actually out. So I can do here std, and let's make this say out to make a use case for this one. You can see now I'm printing. First I access it and then I print it out. All right, let's see now. Perhaps we have now an error, and no, we have no an error. It is still there. So I don't know why they have flagged this as an error, because it is not an error. At least not on my machine. Or I make here something really wrong. So that's why we skip this, and I have researched why they point this out an error. So it makes no sense for me. It is normally it's not an error, but they say it's an error. Okay, I don't see it. At least my compiler sees it's not due. My compiler is assigning a value, it is printing exactly the value out, what I expected. So I don't see it. Perhaps, but perhaps you should not use this one if they say it's an error. Who knows? So, and with that, this delegate constructor, we will talk also in a future lesson. So you see, we have the many topics which we have to talk. This delegate constructor is again a constructor, but yeah, we'll talk about this in a future lesson, which is calling just a constructor again or another constructor. All right, but this more in the future lesson. So, and with that said, I think that's good what we did so far. And we are soon finished with this side. We have some little parts open. There is no worry. And then we have to jump, perhaps, and we will talk this also in the next lesson, this default constructors. And so I think I have not talked about this one. What they all mean here. This other parts here, we will talk about this one also in the next video, one of the next videos. You see, we have much things to talk about, this class constructors and then other class things. But okay, anyway, that's all for the future. So I hope you understand it at least so far, so that you can use that. So, and don't get irritated by this what was it, this reference here that's all time irritating many people, that we can do something like that in classes, because this semicolon, normally you need an initializer there, right? And in classes you can do something that with the constructor. That was the most important part here, I think, to recognize, and all other things are of course important too. But yeah, with that said, if you have any questions like all time, or any complaints, or any tips and tricks, or if you figure out why they say this one is an error and I have not an error, write this also in the comments. Would be interesting. And see you in the next. Good luck, and like all time, don't give up and have fun. Bye.